Welcome to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by London-based Liz Keogh, who is a lean and agile consultant and also a core contributor to JBehave. Liz Keogh, it's a pleasure having you on Maintainable.
Thank you for having me.
So first off, given your experience in the industry, what do you believe are a few key indicators that a software application's codebase is well maintained?
I look for tests primarily. If it's got TDD, it's really, really hard to do TDD on a code base which doesn't have separation of concerns, nice readable interfaces. I find, especially if you're doing the test first, it tends to drive out really nice readable code. So I look for code that's easy to use, code that's understandable. If I'm changing code for the first time, the first place I'll go look for what that code does is the tests.
And when you say separation of concerns, can you elaborate a little bit on that, what that means for folks that might not be that familiar with that terminology?
Yeah, I think it's a single responsibility principle is how people normally phrase it. But it's basically making sure that each bit of code does one thing and not multiple things. I'm quite pragmatic about that. So honestly, if it's three tiny things that all fit together, I'm okay with leaving it until there's a need to separate it out. I don't feel the need to have a perfectly designed code base, but it should be to the point where if you do need to change it, it's obvious what that change should be. Get it to the point where it's refactored just enough that change is easy.
On the inverse of that, what are some common elements that a code base is littered with technical debt and or not well maintained?
The primary measure I use for that is there are bugs and it's hard to change things. You know, those are the big symptoms, obviously. But generally, it's because there's a natural thing that happens. So we tend, when we're doing something new, to spike something out, to prototype something, to give it a bit of a go. And we're not always sure what it is we're working on. And I found the newer the code is, the more uncertain the code is, the more likely it is that it's just been a bit hacked. And I think that's perfectly normal. It takes effort to then get that prototype or that spike into a clean state. And some people are better at doing the hacking and the spiking than they are at TDD. So if you don't have the people who are good at TDD and love refactoring or are prepared to rewrite things, then you're going to end up with a mess. It's going to vaguely work, but it'll be spaghetti. I think that the worst piece of code I ever came across was a 10,000 line class written in C#. And it was a tabbed Windows form, which had buttons and text fields and SQL calls off the button clicks. And the way that it gathered the information that it needed to make the SQL calls was some of it was from the text fields, some of it was stored in these kind of almost models, but they weren't quite. Some of them said, if this flag has been turned on true at any point, go and get the information from here. Otherwise, it's from over this place. You know, it was a real mess. I was there for about 3 months teaching agile processes, agile techniques, and we had it down to about 3,000 lines by the time I left. And it didn't take Visual Studio 5 minutes to load it anymore.
Wow. In scenarios like that, how do you go about helping that team try to prioritize dealing with refactoring? And was your role actually diving into the code or just kind of helping them point them in a better direction?
Bit of both. I'm primarily a coach, so wherever I go, I'm trying to make other people better as well. I'm trying to help them pick up the skills that I've got. I would do a little bit of refactoring and then get them to do the rest of it. But it really was small. It wasn't... Mike Feathers talked about seams in his book, working effectively with legacy code. There weren't any places you could get seams in there, not to start with. It was such a mess. It really was looking for common patterns, common phrases that we could extract out elsewhere until it started to make some sense. And it just got a bit smaller and a bit smaller.
What do you believe developers often get wrong when they discuss technical debt, maybe even as a term?
I don't think it's dead to get it wrong. I honestly don't. I think that a lot of the time, there's a lot of pressure on devs. I mean, Agile, people want devs to do Agile primarily so they can get more done with fewer people, less money. And it doesn't quite work that way. So there's always a lot of pressure on development teams. Unless you've got an absolutely steel backbone, you tend to give in to that pressure by cutting some corners. It's a loss-leading exercise. Tech debt doesn't immediately pay back for itself. Whenever you've got that pressure going on, whenever you've got that sense of urgency going on, it's very easy to go, okay, I'll just code your feature for you, and ignore the fact that you're making it even messier. As code bases grow, that mess is in some ways completely inevitable anyway. I've never managed to design something completely right up front, so I'm always having to tweak things and move things. I remember Kent Beck in one talk when he was working at Facebook. He said he had to make a small change to one of the drop-down menus, and it resulted in changes in 12 places. And he said, you'll be asking me next why I didn't refactor it, but I honestly didn't know the code base well enough to do that. I think as you come on new to a code base, it's always going to be a little bit of entropy. It's always going to be a bit messy. Just clean up as best you can as you change things.
Let's talk about behavior-driven development. And I know that's something that you have spoken quite a bit about over the years. For those that don't have much exposure to BDD, how is it different than TDD?
They're really the same except for the language that we use. It turns out that test-driven development produces tests as a really nice byproduct. So the idea of test-driven development is you write your test before you write your code. And if you're doing acceptance test-driven development, you're writing acceptance tests over an entire system before you write the code. So BDD works at both those levels. In fact, if you can get any module of code, any kind of piece of code and say, can you give me an example of what this code does? You can do BDD with it. But we're using the words examples and scenarios instead of tests. And that allows much easier conversation with business people, because I can't ask a business person, can you help me with my acceptance test? Because they don't want to do that. That's a codey thing. But if you say, can you give me an example? They go, oh, yeah, sure. And they'll give me an example. And it will start from some context. It will have some event that happens and it'll have some outcomes that result. That's actor range assert. So it's exactly the same thing as TDD, just with language that's a little bit more familiar to non-technical stakeholders. We also find that because you're thinking of examples, it's just easier to think of the problem. Whereas when you start talking about tests, we're jumping into solution space. We've already solved the problem and now we're testing that our solution is good. Whereas using examples and scenarios, and particularly that word should that we use a lot in BDD, it allows us to ask, should it really do that? Should it do it in all the contexts? Can we think of any other examples where it doesn't work this way? And we end up with really rich, human-readable documentation for the code that shows at a system level why this system is valuable, what it's doing, and at a class level, why each class is valuable, how it's fulfilling its responsibilities. If you're using mocks for delegation, how it's delegating things to other classes. Also with functions, it's exactly the same with functions. Functions also have behavior, the parameters you pass into them and the context, the things you get out of them, the outcomes. So it helps to document the code. It helps us to think about our responsibilities, both of what the system should do and what a class should do. It just helps to keep it clean. If you're doing it as a class level, drive out some really nice design.
Have you found that during like a spike on a project or people working towards their initial MVP, that it's been helpful for companies to go through that process and use BDD from the get-go? Or is this, I have this idea for an application and it's going to be useful, but I'm going to see if it has any market fit or whatever. But my own experience is there's companies that will really try to focus on all of that, and then they have really slow development process potentially as a result because they're trying to really bake in a lot of things early on into their process. Yet I often think that sometimes that's an excuse for them maybe just not having enough experience with BDD or even following with test-driven development methodology. Do you find that it's a little difficult to kind of squeeze that in later, or have you seen that work successfully early on in a startup type scenario?
I tend to find that when you're working with highly uncertain code, BDD is not a good thing to use in terms of code. So not doing automation. Automation is a commitment. If you're committing to the wrong thing, it's expensive. Conversations are really lightweight. Writing them down is really lightweight. You can still write the scenarios down that you're thinking of. And certainly if you're basing your spike or your prototype on some stuff which is known and is well understood, like you've got a GPS system. GPS systems aren't going to change. You can test drive that. You can write your scenarios and examples around that. So there'll only be a little bit of it which is spiked out. I remember when we were doing a new UI for a trading company. I hard-coded it. So there really wasn't a lot of behavior in that. The hard-coded parameters, there was no database, there was no model view controller. It was literally, here's a thing, play with it, see if you like it. And there was no point trying to write BDD around that. But I love refactoring. So when we got it roughly to a right place, I started stabilizing it and wrapping some tests around it and doing all the good stuff.
So it's not always a tool that you always need to implore, but maybe there's parts of it that you can take advantage of earlier on in the process and then make that commitment later on to go in and start integrating some automated tests and such.
Yeah, absolutely. Dan North coined the term spike and stabilize. I think it was his term. So, he's the creator of BDD and he does this too.
I want to talk a little bit more about technical debt. I know you touched on a little bit about how it's not like credit card debt. It doesn't immediately pay for itself. What did you mean by that?
So Steve Freeman had a really great take on this. He says it's more like an unhedged call option, which basically means a call option's right, but not the obligation to get something. So I'm a cocoa bean manufacturer and you're a chocolate producer and you buy an option from me to buy cocoa beans at a really cheap price because you're worried about the harvest. Now, it's a put option for you. It's a call option for me. I have to provide cocoa beans to you. But I didn't hedge the option. So now the harvest is really bad. It's very, very dry. There's no rain. And I've only got a few cocoa beans and I have to sell them to you at this really cheap price because you exercise your option. It's like that. It's fine. It's cheap. It's cheap. It's cheap. There's nothing going wrong until you get called on it, until you have that dry spell, that urgent production bug, that regulatory change with a deadline that everybody forgot about, and suddenly you have to change it. And then it's really, really expensive. Or, there's some urgent opportunity in the marketplace and you can't move fast enough to take advantage of it. So it's got a cost to it. I think people call it intangible in terms of the cost of delay. You can't really know what the cost is, but it's there. David Anderson says, if you leave everything long enough, eventually it becomes an expedite. It becomes urgent. It becomes something you absolutely have to fix. And I think the trick with tech debt is to get it to the point where you can afford to pay when you get called.
Do you see that in some of the projects you've been part of or over the years, that like a good process for how to address the technical debt or some of the areas of the code base that do need to get refactored effectively? Like I've heard some people talk about a percentage of their development time is spent on maintenance type of work or refactoring type work versus building, just working against what the product team is asking for in their backlog and like trying to figure out some ratio there. Have you seen anything effective in your approach for that?
Yeah, Simon Wardley with his Wardley mapping, he talks about 3 different types of work. So you've got the really new stuff, which is Genesis custom built. You've got stuff which is stable and it's your product that's in the marketplace. And you've got really, really commoditized stuff that the architects are all over. And then he talks about pioneers, settlers and town planners. So your pioneers are going to do the spikes, the prototypes. They're going to stake out the new ground. Your settlers are going to be the ones who stabilize it and turn it into production-ready code. And then you've got your architects and your town planners. Hire settlers. That's what you want to do. You want to be hiring some people who really love refactoring. I assumed everybody loved it as much as I do, but it turns out that actually you have to be a little bit OCD and you have to care about making things clean. And I care deeply about my clean code. I love refactoring for fun. I love writing tests around things, and you want people who want to do that. You also need the pioneers who like spiking and hacking, and some people are bit good at both, But again, people have their strengths. You don't want somebody who's really, really good at the high uncertainty R&D and can get stuff working and throws it over the fence if you don't have people who are willing to catch it on the other side.
Who was that again that kind of phrased those 3? I'm curious about that, the pioneer settlers.
Simon Wardley mapping.
Yeah, I like that kind of description. I think one of the things that I've seen used in some areas of my corner of the world in software development, there's people that are kind of see themselves as a lot of maker type. It gets kind of thrown around a little bit like we're makers, but of software, like building new apps and startups. And I find myself being more of a mender, I think is another way of describing that. I like to mend things, like to make things that already exist, make them better than they were when I found it. And I feel like that kind of has a similar vibe to it. And I like this pioneer settlers architects approach. Good language there.
So it's funny you mentioned startups. They have this dynamic where everything's really, really urgent and they literally don't have time to stabilize everything. So a lot of manual workarounds going on in the background. A couple of people know the code base really, really well, and they don't need to refactor it, and they don't have the funds to refactor it. They've got to get something working. They've got to get money in. And it's only when you actually start growing and you start seeing them become 50, 70 people big that tech debt starts to bite. So I think it's always inevitable for startups, particularly, if you're bootstrapped or you haven't got a lot of venture capital. It's always going to happen.
It's true. Let's say that there's a listener on the podcast and they have a software project that doesn't currently have any automated testing. Let's assume it's a small web application with maybe a backend portal for internal staff to use it. And maybe there's another portal for their clients or customers under this one application. If you were to advise them on how to start taking steps to begin introducing some automated testing, where would you suggest they start?
With the changes they want to make and have some conversations. Usually when I get called in, I've found that people have already started with BDD, but they're not really having conversations. So they've got the tooling in place, but the tests themselves, the scenarios themselves are unmaintainable. So they're usually a bit too fine-grained, lots of clicks and text boxes, and it doesn't really describe what the application's trying to do. So I get them to stop and just have some conversations. Just get used to writing those conversations down. Can you give me an example? Great. And focus on the areas where you're making change. I don't believe in rewriting things, making things maintainable for its own sake. I think that if you're trying to change something and you don't understand what a piece of code does and whether it's relevant, then that's a really good time to be refactoring it as you work it out for yourself so the next person doesn't have to. But just going through and just cleaning up code for its own sake, unless you're the person who wrote it and it's still fresh in your head, so it's time saving for you to do it right then, just refactor as you come and change it.
Do you find that when it comes to testing different aspects of a code base, have you seen any ratios also for things like when to use more unit tests versus integration tests, or some sort of ratio that you kind of advocate, or beyond that?
Definitely more unit tests than end-to-end tests. End-to-end tests being really expensive. I can't think of any code base which I've produced where that hasn't been true. Yeah, I've always had more unit tests than end-to-end tests. So obviously, testing pyramid is a thing. How many? I always say just enough that you can understand the behavior of the system and put the interesting tests at the top of the feature file. If you've got something where you're processing a refund with a discount, you don't also need to include the one where you just process your refund without a discount. You just take that one out. It's covered. Just leave the interesting ones in.
And when you said that end-to-end tends to be more expensive, can you elaborate on that? What you mean by that?
UIs are harder to do tooling around. If you're doing the whole stack, you're probably looking at I/O and there will be delays. So I remember one project, we had stand-ins for even the file system. So we were able to run end-to-end scenarios with 100% CPU. That was a goal, and we managed it. But we had to hack Jetty to do it, and we weren't going through the user interface. We were going through the controller layer, and there was a bunch of stuff that we did which was taking shortcuts. So it wasn't the full system. As soon as you're starting to do things like go through the UI, where you have to wait for a browser to render the DOM, going through a file system where you have to wait for a file to be read or to be written. I've got one test at the moment which is actually loading a big chunk of Skyrim. That takes some time. It takes about 45 seconds. That's slow. That's really slow. Keeping a code base down below 10 minutes is hard in that situation. And above about 1 minute, devs switch off. And now we're not paying attention, and we don't run them all the time because it's just too slow. So you want the important scenarios to be end-to-end. I always say put one example of validation in there and then all the rest in unit tests, unless there's something really tricky and interesting about the behavior of the validation. One is plenty. Just checks it's still wired up.
You earlier touched on refactoring and really enjoying that. So it's safe to assume that you're probably more often on team refactor than team rewrite?
I am. Having said that, I end up rewriting bits of code. But rewriting the whole thing, no, not so much. We did rewrite the whole of JBehave, but that was because a lot of the features were actually redundant. They had been replaced by better systems.
When do you believe it's appropriate to perform a full rewrite outside of that example?
It's easier to do the full rewrite than it is to actually refactor the code. I mean, it's a blasé way to measure it, but microservices, You can rewrite a microservice, some tiny thing that if you change it, just rewrite it. If significant chunks of it have been made redundant, so going back to Wardley mapping again, Simon Wardley says eventually everything becomes a product, and the things you custom built, you don't need to custom build them anymore. Somebody's got a really great example out and you should just be using that. And it may get to the point where you've got enough features like that actually just rewriting the little core that still remains is the right thing to do. So JBehave 1, we had a mocking framework that got replaced by Mockito. We had a version of JUnit that used the word should instead of the word test. And then JUnit used annotations. So it was much easier to start your test with the word should anyway. We had a swing automation front end, which was my thing. That didn't even belong in that project. That belonged in its own project. I think extracting out those responsibilities until only the core remains and then see if it's worth rewriting it. We were working with a totally new paradigm with JBehave 2 as well. It wasn't just because it was tech debt. So don't rewrite just for tech debt, I think is the answer. If we can get a 10,000 line GUI class looking better, down to a third of its size, with responsibilities started to be refactored out, then I think you can refactor most things. Having said that, I generally only work with statically typed languages. If you have a dynamic language, you might end up needing to rewrite things, just because refactoring is really harder. It's much, much harder.
Let's talk a little bit about team processes for a moment. So as a consultant, I'm sure you have a lot of experiences of being a guest in one of your clients' code bases. What do you think makes a good guest when joining an existing team to work with them on their project?
I'm a super introvert doing an extrovert job. And I know a lot of devs don't like to pair because a lot of us are introverts. We like to have our own space. But if you're picking up somebody else's expertise, driving and letting them help you through navigation is usually the way to do it. Pairing, 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 always pairing. Don't be afraid. Step into new pieces of code. Step into new languages. I surprised myself enough times with what I was able to do, even with code that I did not know at all, that I think everybody should give themselves the chance to do something really, really new and totally unknown. So I fixed a bug in a retail mobile app. I've never done mobile work. I've not done a lot of JavaScript. It's just code. You can work through it. You can read code. It wasn't the worst code in the world, so it was at least understandable. But I learned how to trace through it. I learned how to get a mobile emulator up. I learned how to read Google Chrome DOMs and all that stuff that web devs take for granted because I've never really worked in web a lot. It was fun.
That's nice. Pairing with people and working with these people that are part of a team, are these types of scenarios where you're coming in as more of a consultative type approach to start helping them with the refactoring? And so is this kind of like early part of that process, or are there also just types of projects when you're being hired to be kind of, I wouldn't say staff augmentation, but something kind of like that where you're coming in for a period of time to help them speed up their process?
It's been a while since I did proper staff augmentation. Having said that, I still code for fun. I still occasionally get to pair. I still have plenty of stuff on GitHub. I think as a consultant, I don't necessarily come in and go, you need to refactor this. I come in and I say, tell me about how it's going, how are you working? It might be that they've got other problems, which mean that refactoring is not their biggest priority. And if I come in and say, you've got to refactor this, I'm not actually doing the most important thing. So I work a lot with complexity thinking these days, and Dave Snowden, the Cynefin framework, he's into sociology and anthropology, and patterns in human systems, complex systems are emergent, and the practices are emergent too. If you go after a practice directly, it's often the case that it just won't land, and you'll get people saying, no, that won't work here. We've tried. It doesn't work. It doesn't work. So if you get that, I might, instead of saying you need to refactor this, say, hey, have you tried asking for an example when you talk through your requirements? Or I might say, have you tried pairing? It might be that those lead to refactoring further down the lines, but I'm not attacking it directly. I think that's really, really important. I think for a long time in my career, I was getting that wrong. I was telling people, this is what good looks like. You should be doing good, rather than what you are doing is good. Have you considered all of these different ways in which you could make it better. Which ones interest you? Which ones look like they're things that you plan right now? And a little bit of better buys a little bit more space, which buys a little bit more better, which buys a little bit more space. And eventually they've refactored the code.
What are some ways that you've seen teams effectively organize and prioritize those refactoring type projects? I know there's always the conversation that maybe stakeholders aren't allowing them to prioritize that. And that's a conversational problem between the development teams and, say, the product owners or whoever else related to that piece of software. But what are some effective ways for developers to kind of, without coming up with a better phrase, sell their need to make some improvements to the code base effectively?
Do it as you're making changes. Do small refactorings all the time. Every single developer goes through one phase where they start refactoring something, and 3 days later, they've realized they've bitten off far more than they can chew. And then they have to reverse it. And then they start again and they check in small changes, small changes, small changes. And I think that's how you learn to do small refactorings. Almost just every dev I know has had that big 3-day refactor they've had to revert. I think when you do that, you start seeing more easily what the small changes could be. So just start making the changes the way you think. And if you can check it in, do. And if you can't, expect that you might lose 3 days. It'll be a learning experience. Yeah,
there's always those branches you might have where doing all this stuff and then you're just like, I just don't know when this thing's going to... You can't see the light at the end of the tunnel, even though you thought you did at the beginning. A little bit of a mirage at times. We'll be back with my interview with Liz in just a moment. Hi, it's me, Robby. I want to thank you for listening to the Maintainable Software Podcast. If you're finding these conversations valuable, please consider sharing it amongst your peers and or writing a review on Apple Podcasts to help spread the word. Also, if you have a good story or two to share about ways to improve the long-term maintainability of software and help write software that lasts longer and might be interested in being a guest on the show, please get in touch with me at Robby with a Y at maintainable.fm. And now, back to our interview with Liz Keogh. I wanted to touch back a little bit on BDD one last time. And, when you talked about examples and scenarios, I'd like to hear a little bit more specific types of scenarios that you've maybe recently encountered that help developers kind of get an idea for what that kind of might look like a little bit, even though they're listening. The reason I'm curious about that is that I've seen people sometimes correlate user stories and writing scenarios for BDD as being the same thing in some ways. Or do you agree with that statement? Do you feel like a user story is a scenario, or are they actually a little bit separate?
They are definitely related. For me, a scenario is a story is a slice through a bit of the behavior that you can get feedback on. So it might be just one scenario. It might be a bunch of different scenarios. It might be a hard-coded UI. Traditionally, stories are things you can ship, but often when we're working in enterprise environments, we're after feature parity with something, or we're waiting for some dependency that it's with a waterfall team. There's a lot of reasons why we're still developing the DevOps skills to actually be able to ship regularly. There's a lot of reasons why we might not ship. So if you're not going to ship, getting feedback is what makes a story. If you can't get feedback on it, it's a task and you won't be able to tell it's working until you've actually carved it up. So yeah, scenarios could be a story. There are other things that could be stories. I think it's okay to produce a hard-coded UI, which has more than one feature in it, if that's the thing that you want to get feedback on. I've definitely seen teams, as they get more familiar with BDD, starting to carve off scenarios from bigger features. So they stop making small user stories and they start going, here is the capability. We need the system to be able to do this thing. We need our users to be able to do this thing in this context, with this other outcome. And they really start carving off those scenarios and just flying through them one scenario at a time. And you'll see their check-ins become a lot more frequent as well.
One of the things when I was doing a little bit of research on you, and I was watching one of your talks, I think it was a couple of years ago, maybe the GoTo conference, and you were talking about building leadership in everyone in a team. And I was kind of curious if you thought how that could relate back down to a developer working within a team of, say, a couple developers, and to help them see that they can be a leader in the areas that they're responsible for.
Generally, I amplify whatever's working. I amplify positives. So if I see that they've done a really nice example of TDD, I'll call it out. I'll be like, that's a really nice example. Can you show it to this other person who's really new? Because they're picking up TDD as well. Can I help you put together a workshop on this? Can I help you do a presentation? I think amplifying those positives and helping people to share them as well. It's so much more powerful than me sharing my examples of TDD. I'm usually an outsider. I'm known as an expert. Everybody's like, well, of course you can do it. But to see that everybody within the organization can do it, that's massive. I've seen a team of people that I would describe as mediocre devs. They're not the best devs in the world. They're mediocre. Some of them are quite junior, only a few years experience. And just teaching them a few basics and then amplifying everything they did that was good. They managed to produce one of the cleanest code bases I'd seen. That's just amazing. That's just really lovely. And it's because when you start amplifying that stuff, when you start getting them to share it, they gain so much more confidence and they're willing to do those fearless things. They're willing to share with each other. They're willing to pair. They're willing to take those extra steps.
It's a really good point. I've seen it in my own experience, even me as someone that oversees a team of developers, that sometimes I think there's a lot of expectation that feedback and amplification of people's strengths or things that they're doing really well needs to come from their managers. Or maybe that's where they perceive it being most relevant. But I also think I agree that there's probably a lot of benefit to making sure their peers are also helping amplify them and vice versa. And sometimes that's like people feeling like they don't get enough feedback and it becomes a management problem, but it's also like a maybe systemic problem that the team as a whole isn't providing enough feedback on those sorts of things. Especially if you have the advantage of having processes in place like pull requests, where you're actually getting exposed to whether the people who are on your team are working, if you're not directly pairing with them all the time.
There's actually some huge parallels between giving feedback to people and working with code. If you're working with legacy code and you want to make a change, the first thing you do is you get the bit that you're about to change under test so that the behavior you value is anchored and you don't change stuff that you want to keep. That's the same as amplifying what people are doing well. That's the same as saying that's really good, right? So that's what that feedback is. It's amplifying, anchoring the things you value. With code, you then describe the behavior you want, which is a failing test. So you've got your code under test. Now you're going to describe the change. You write a failing test. And then you write the code that makes that pass. But people write their own code. You don't actually need to tell them they're failing. All you need to do is describe where you're hoping to get to. And they fill in the gaps. It's such a beautiful way to give feedback. I love what you're doing here. How do we get you to the point where you can share this with other people? I really love what you're doing here. Have you seen this code pattern? I think it would be applicable here. I'm not telling them what they're doing is wrong. I'm just describing what better looks like. And if they want to do it, they'll pick it up. And if they don't, find something else. Don't hit the stuff that they don't want to do. There's so many ways to improve in a team. There's so many ways for a person to improve as well. Once you've actually got that behavior anchored and once you all understand where you're trying to get to, that's the point at which you can do that thing called radical candor. That's the point at which you can say, hey, I'm going to say something because you know that I value you and you know where we're trying to get to. Take that within this spirit. Here's the thing, right? And even when I've done that, it's been with all of those words I just said, that I'm doing it because we understand what I value about you and we know where we're both trying to get to, and it's with that. So that radical candor has to come from a place of care. Otherwise, it's not radical candor. It's just being an os. And that's not very nice. So I think making sure that you amplify the positives all the time, making sure you talk about where you're trying to get to, multiple different options for ways that you might get better, and then let people close that gap themselves. Once you've got that rapport, once it's really well understood, then you can start saying, hey, I think we should work on this bit of the code base. Hey, I think we should be doing this a bit differently. I think we should adopt this agile process. I think it's time to try BDD. But you can't do it unless you've got that rapport already. Same as you can't change code until it's under test.
I really love what you're saying here. As you're talking about this, I'm starting to run through some of my own examples of things that in the last few days at work where I feel like I could have brought something up a little bit, maybe a little bit more positively than I did. And so I hope there's people listening also think about that. You can make some pretty powerful changes within your team starting today with some of this advice here. So I want to wrap things up a little bit. What book do you find yourself recommending to software developers most often?
Martin Fowler's Refactoring book and the Phoenix Project. I think developers take on too much at once a lot of the time, and that context switching is really, really expensive. Also, limiting work in progress forces people to pair a little bit, forces them to collaborate, share their skills. So the Phoenix Project is all about that.
And where can people learn more about you and your thoughts online?
LizKeogh.com. I've got a blog there which has been running since 2004. If you go to December 2004, you'll find a blog post there which is celebrating the first time I got a green bar in testing. So, you can actually see me going, yeah, I got a green bar for the first time ever. This is so much fun. We all start somewhere. So I hope that whoever's listening takes that on board. If you're junior, if you're new, we all start somewhere. And I started there too.
Well, really appreciate you joining us on this episode of Maintainable, Liz.
Thank you very much. It was very enjoyable for me as well.
Maintainable.